Yes, good morning. Thanks for attending, and if you'll bear with me a little bit, I'll try and bring you up to date with where we're at. What we are finding is that we know silica sand consumption is huge now, predominantly by concrete, and then following that is glass, and then probably the foundry industry. But we're finding that more and more glass products that silica sand can go into. Now, we're not investigating all of them, but we're investigating quite a number of them. And we know this from the number of inquiries we've been getting to buy our silica sand. Now, some of the other uses, tyres, for example, it's in the hundreds of thousands of tonnes, whereas glass is in the millions of tonnes. But, you know, the other components around the place, LCDs are becoming more and more prevalent. And the demand for silica flour to make LCDs, thin film transistors, same thing, is becoming very, very strong, and we are going to be investigating that. But we do find that it's an enormous number of products that silica sand eventually goes into. We own the 4 projects. We've got Mushay just north of Perth, Aerosmith Central and north, just between Eneabba and Dongra, and Boyatup down at east of Esperance. Now, we're concentrating at the moment on Aerosmith North, and I'll explain why we're actually doing that, but there is a strategy in place for that. But what we do have is very, very long life projects. These are going to last potentially 100 years. So, you know, we need to get all of our approvals in place to substantiate a very long-term project. So these are probably the most advanced projects in WA, mainly because we started on most of the prerequisites in 2017. So we've been at it for a while now. Mining leases are granted on 3 of the projects. We actually have a mining lease and an additional mining lease application in at Aerosmith, which once that gets further down the track, we'll be announcing that. And really, it's the interesting customers from Southeast Asia, or in Asia itself, the Asia Pacific, is still predominantly for glass. So Aerosmith North can go into the flat glass market, which includes automobile glass, and there's a huge amount of demand there in Korea and Japan, and growing rapidly into China. Doesn't matter whether the car's got an electric motor or a internal combustion motor, same amount of glass goes into them. So the glass supplies for vehicles is a very interesting market because they don't recycle any of it. When they go and crush a car, they're quite happy to leave all the glass in there because they have to add silica into a blast furnace in any case as a flux. So if there's glass already in there, it's less silica that they need to add. So there is almost zero recycling of automobile glass. And also the laminated glass on the windscreen, that is very rarely they do anything with it other than throw it down the tip, because the laminar, the sticky bit in between the layers, is quite toxic if you go and heat it up. So we're looking for very long-term, large-scale projects here. The other important thing is that each of these projects produce different sand, and that's in not necessarily, when I say quality, it's not necessarily the mineralogy, but it also may be the size and shape of the grain. Now, that determines which market it goes into. So really the point is sand is not sand is not sand. So in fact, the products we can produce from Aerosmith North and Central and Mushay and Boyatup, they're all subtly different. And because of that difference, they go into different markets. And that's quite important because we don't have our project competing with each other for market share. The reason why we selected the ground that we've got is, one, we're able to get a very large area. They are all on what's called unallocated Crown land. So it's was termed vacant Crown land. And they got railway lines next door to it, except for the Esperance project, but that's got a bitumen road runs right all the way up to it, all the way to the port, and gas pipelines, and that's becoming more and more important. WA is rapidly becoming the cheapest gas in the world, and that offers up opportunities for potentially glass making here in WA, mainly because about 80% of the cost of producing glass is energy. Now, also, that LNG can be replaced by hydrogen. Nippon Sheet Glass in the UK actually produced glass using hydrogen, so it can be done. Technically, it can be done. Midwest is going to turn into Hydrogen Central for WA, and we're right in the middle of it all. So there's certainly more opportunities there for it. Aerosmith North, we still think we can get up and running in 23. Depends a little bit on the EPA, and I'll run through that sort of timeline. It's got very large reserve. We put out a new reserve statement a couple of weeks ago, and we've now got the first 6 years production in a detailed schedule. So we know what we're producing block by block through the first 6 years. And we grade controlled that some time ago. But more important is that we know what products to produce. So the reserve is not tonnes of grade, it's actually each of the 4 products that we can produce from Aerosmith North, block by block. So we can look at quarterly production for the first 6 years. And that's quite an advantage, particularly when it comes to financing. We're able to approach financiers and say, look, here's the detail of the products we can produce for the next 6 years. The railway line to Eneabba to Geraldton runs adjacent. We're in discussions with ARC Infrastructure, who own the railway line, and we have an MOU in place with Midwest Port, looking to coordinate those two over the next few months. We've finished drilling the bore. The bore is quite deep, it's 300 metres down, but got more than enough water for us, good quality water, and certainly suitable for processing. And we're in the process at the moment of producing a water abstraction model, I should say, to apply for an abstraction licence. It's a 2-stage process to get water from the Water Authority. One is you get a permit to construct a bore, the second one is you get a licence to abstract it. And that's subject to pump tests and also modelling the whole region to determine what the effect will be. I think we can draw down for 3 days and it moved at about 0.1 of a millimetre. So it's an enormous water resource. Brand Highway, we just got approved the intersection design for us to get down through Brand Highway. Gas and solar power supply, we've been talking to quite a number of power providers. We went out to tender and we've reviewed the tenders, but we've had a late approach, and it's a very interesting concept, and that is to put a power station at a wellhead, at a gas wellhead. We've got half a dozen gas wellheads within about 10 kilometres of us. So they would be able to access the gas after it's dewatered, but before it's pressurised to go into the gas pipeline. Most of the cost of producing or using a gas-fired power station is that you have to decompress it. Now the decompression station would cost as much as the power station that we would want to put in place. So we can get it before it's compressed and then reticulate power down to us. So there's no transport cost for the LNG, and that saves a lot of money. It's probably the cheapest power solution we could possibly get, way cheaper than solar and wind. So, but we're still considering a hybrid system, including solar. But that's an interesting development that we're working on. Aerosmith North, the mining approvals. We lodged in June of this year what was called the ERD, Environmental Review Document. And that has in it all the detail that's required that was already agreed to with the EPA in the prior document, the scoping document. We put that in place. We actually got comments back this week. we were promised to get these comments back in June. And in fact, in the ESD is a timetable for the approvals process, which is dictated to us by the EPA. And we assumed that they were going to hold up their end of the bargain and meet their own timetable. Wasn't the case. We've only just received them. So they're 5 months late. Now there's a number of reasons why that's happening. One is that we're applying for a very large area. The first application is for 350 hectares. The next biggest sand mine is in WA, in the Swan Plain, is 35 hectares. So we're 10 times bigger. So we're always going to get a lot more scrutiny because it's so much larger than anything else they've been given. So, or asked to assess. Also, we want to use vegetation direct transfer, and I'll show you what that means. It's a process which we think gives a far superior rehabilitation outcome, but it's never been approved before. Nobody has lodged an application using VDT. So that in itself will get a lot of scrutiny. Very fortunately, Silica have conducted trials, and the environmental consultant we use to do our consulting work also does the work for Silica and has been surveying this plot, this trial plot, years 1, 2, 3 and 6, and it's sitting there about 8 years, and she is adamant it is a far superior method for rehabilitation, particularly where we are in the Quangan Heath. Now we expect to be able to respond to these questions we got in the next month, and then hopefully it goes out to public for 30-day public publishing. Unfortunately, Christmas is in the middle of there, so that's going to take a little bit longer. We'll also lodge, we've already drafted, and we've been waiting for these comments to come back to finalise the draft to make sure we're addressing any of the concerns in the comments, and then we'll lodge that with DMERS, and that'll run in parallel. Aerosmith Central, it's sitting there at that ESD, and we lodged that also in June, and we've heard nothing back on that at all. But we've also been told they're not going to look at it while they're looking at Aerosmith North. They just don't have enough people. But we've prepared the ERD, and also we'll be cognizant of the comments we get back, and we'll put those into that ERD as well. But it's all about this vegetation. It's only about waist high, but more importantly, the root systems only go 200-300 mil. So the method we're looking to use is to take out a 400 mil sod. These don't have deep roots, and more important, no tall trees. So while there's no trees, there's no nesting or roosting opportunities for Carnaby cockatoos. And they're at the top of the list as well. Muche, we've still been doing work there. We've actually conducted quite a bit of metallurgical test work, in a similar vein to all the test work we've been undertaking for Aerosmith North. But it's ideally located. It's got an underutilised railway connection. It's only used a couple of weeks to haul wheat from Moora. There happens to be grid power there. But again, very important is that there's 2 gas pipelines. So we are actively pursuing the opportunity to have a major glass producer come to site, and we would put in a contract to supply sand to a glass production here in WA. But it's close to Perth, and it's located. We've got buffer zones that far exceed any of the guidelines. Access is got a bitumen road almost up to it. We've got a mining lease that's been granted. We've got a number of miscellaneous licences to connect from a couple of the roads up there into the site. The test work has become quite interesting, but we can produce less than 100 ppm iron. it makes it of a quality that makes it very high demand, because from it you can make ultra clear glass. Now, the ultra clear glass, the demand for that at the moment is for the piece of cover glass that goes over solar panels. And that's a market that is growing at about 30% per year. Everybody who is producing glass wants to be making solar panel glass, and almost all of those manufacturers have contacted us. The manufacturers of that glass, the top 10 in the world, are all in China. Sorry, they're all Chinese companies. A couple of them actually operate in Malaysia. But it's that whole industry is dominated by China. But there are lots of other companies, major glass producers in Korea and Japan and Taiwan, who want to get into that industry in a big way. And they're the ones we're talking to, all of them. A couple of the major ones are coming down here to do site visits. But it's a very important raw material. But we're also discovering that the other raw materials required to make glass, we can get here in WA. One, the LNG is cheap and there's plenty of it. Lime we can get. Dolomite we can get. Soda ash we can make out of LNG. They're the main components that produce glass. There's not many involved in it. The big one's the energy, LNG. So we're finding we can produce glass here and really potentially be a major contributor to the solar panel industry. Mucho's a bit different. The vegetation's different. It's the low grasses, sedges that grow in here are the recalcitrant species. These are the ones you've got to be looking out for. The Banksias here, they're not difficult to propagate and easy to replace. Now, they do have relatively deep roots, but the sedges and grasses do not. So this heath is what we're looking for again, and it's quite wide-spaced. And we've developed this vegetation direct transfer. We've been pushing this for quite a while. It's taken the government quite a while to get a handle on it, but we think it's certainly worthwhile. And we've got a bit of a video here that explains what we're doing.
VRX Silica has developed a mining and rehabilitation method that will ensure a rapid and extensive regeneration of affected land. A section-by-section approach ensures that rehabilitation takes place continuously, not just at the end of the mine life, and with topsoil containing the vast majority of the native flora and invertebrate fauna preserved, with the near-surface humus and its microbial contents intact. There is only ever a 150 by 150 metre section cleared by the mining operations at any one time. The topsoil of each square is preserved intact and is moved to a previously mined area immediately on extraction from the ground. The mined area is accessed by just a temporary track, sheeted with mulch. No permanent constructed road access is required. The mining takes place in a 150 by 150 metre cleared area with up to an 8 metre mining face by a single front-end loader. No trucks are involved. Sand will be loaded by front-end loader into a feeder that moves along a conveyor which sends sand to a rotating trommel screen where the sand is slurried. The conveyor is extended as the mined area travels further away from the trommel screen where the sand is pumped to the processing plant. The processing plant will be powered by a hybrid solar, wind and gas power system. The trommel screen and the associated process water tanks will be positioned such as they will not be relocated for over 10 years of production. Only the feeder and conveyor will be relocated. VRX has undertaken extensive vegetation mapping of the mining area and beyond in order to ensure that the flora and fauna is confined to Kwongan Heath and doesn't include Carnaby cockatoo nesting or roosting habitat, and also doesn't include the drainage areas surrounding the site. The key aspect to this is the modified front-end loader that will be fitted with a specialised scoop that will take a 3 metre by 3 metre by 400 mm sod of the topsoil for immediate relocation to the previously mined area. This aspect of the rehabilitation will be continuous throughout the mining process.
You can't get a lot simpler, we think. And it does a couple of things. One, it tends to keep the same mosaic of vegetation. We're moving at 100 metres, but that variation we get in different vegetation types, it keeps it there. So it's a simple process. We've had some small scale trials already up at Aerosmith North, and we're about to construct one of those buckets, and we've applied for it's called small scale mining permit for Muche, and we'll go and trial it up there as well. The plant itself, it's also pretty simple, but a bit unique. We've got in here, where it says hydrofloat here, we're not using, you'll notice there's no spirals involved. So we've developed this technique of using a hydrofloat to remove felspar. And the felspar tends to hold most of the impurities we don't want in the sand. So to get the felspar out, we can clean up the sand to whatever quality we want. That the use of the hydrofloat is actually part of a patent application that's underway at the moment. But this is hot off the press. This is this morning. This is rendered from the plant design. I'll have to talk you through it. We don't have any narration on this yet. We haven't quite decided whether using a processed water dam or processed water tanks, but there's quite a number of pumps here that feed into different parts of the plant. The feed comes in from that trommel. It's pumped into this tank here, which is a conditioning tank, which really conditions it for density. So the whole process here has to control density, and there's lots of trick gear around for being able to control that. But it comes in here first. This pump here ends up pumping it up to the next stage, which is cyclones. And saying you control the density here to control the efficiency of the cyclones. Cyclones are up near the top here. And this is built for 300 tonne an hour, and it comes out of these cyclones to these components, which are nice and blue down here, which are attritioning cells. Now, the attritioning is the key to this whole process. And in fact, the whole process is built around the attritioning to get it into the attritioners, which run at 70% density, and then deal with what it ends up producing. And attritioners are just an agitated slurry. The grains run on grains, and it polishes each of the grain. And then the rest of the process just gets rid of the clay that you've polished off each of the grains. So it comes back down here, and it's conditioned here again, and we put some reagents in here. These are non-toxic, and they in fact oxidise in a matter of days when exposed to the air. And from there we pump it to the top of the plant again, up to the hydrofloats. And at the hydrofloat we're actually taking out impurities as well as the clay that we've produced from the attritioning. The clay, strangely enough, is actually a product that we can sell. It's a great soil improver, especially around most of our projects, because all the local agriculture is in quite sandy soil, so adding clays in there is good water retention. But it comes out of them into these columns here are classifiers, and from the classifiers, these are very flexible. It depends on the water velocity, but you can cut the sand at different sizes. So we can produce different products quite accurately. We've been able to demonstrate that quite accurately. And from there, the different products come down into different bins, and each of those bins then go out to stacking. So It's not particularly complex, this part of the plant, but you will notice there's a lot of steel there. One of our problems at the moment is we'll probably have to go to re-tender early in the next year because the price of steel's gone up about 50% in the last year. It's good for BHP and Rio to get a fortune sending iron ore up to China, but somebody's going to pay. We actually need 3 loaders in the whole operation. They've drawn a few extras in here. And we can stack different products. So those products are, well, the tech sheets are on the website, but those products are within our latest reserve statement. So it's a relatively relatively simple system, and it's sure as hell far less complex than sulfide flotation plants or gold plants. So we're working on that. We're very conscious also of our ESG responsibilities. We're working on reducing emissions. If we can get gas from the wellhead, that's a very low emission result for power. We're in pretty well, for Aerosmith North, we're in constant contact with stakeholders, local Aboriginal groups, but also the Irwin Shire. As it happens, the nearest farm is about 3.5 kilometres away. The next one's about 8 kilometres away. Donga's 30 k's, Eneabba's 30 k's. So there's not a lot of people being affected by this project. Industry innovation, we think we're doing quite well there with our flotation. It's a much better result than trying to use spirals, and it is quite unique. Certainly sustainable. This will be in this location for about 100 years, we think. So we're constantly aware of this, but the opportunity to reduce emissions, reduce the impact, try and mitigate any of our operations there. The opportunity is now. In the planning stage is when you want to get most of these done. We've got another number of initiatives. IAF, Incentive Attraction Fund. It's a state fund. We've applied for $2 million, a $2 million grant. We've been shortlisted for that, but what we're looking to do is produce silica flour. Now, what we have found from the test work at Muche is that we can remove a certain fraction that only goes about 50 ppm iron, which is very, very low for the industry. But if we grind that into a flour, 12 to 45 micron, it goes into quite a number of industries. And the one we're seeing incredible growth in is the production of silica gel, which is the thermal protection in lithium batteries. Now, the big industrial batteries catch fire fairly regularly, unfortunately. So this silica gel, and we've spent some time with a group, an engineering group, who can now develop what they call a 1 hour delay. So the world standard for that thermal protection is 20 minutes. So if one battery pack catches fire, it takes 20 minutes for the next one to catch fire. These guys have developed one hour. They cannot get enough silica flour. And an initial investment of about $4 million, we think we can do about 6,000 tonnes a year into a flour. And yeah, that's bagged and containerised, but there's a huge market for it. And in fact, nobody knows how big the market is. I mean, if somebody said to you now, how big's the lithium battery market? Who knows? So, and they all need thermal protection. So it's in a similar situation, but the people we've been talking to have all said it's a market that is just going through the roof. So we will investigate this in any case. If we get the state government grant, we'll be able to accelerate that program a bit. The critical minerals prospectus, I think will be announced about the 12th of December. We're in it. It's produced by Austrade, and Aerosmith North and Muche are both in there. Now, it's generally a promotional document for Austrade to get other people interested. That hasn't been our problem really, but it's important to get recognised that silica, or in their case silicon, is a critical mineral, and it is for sure. So it's all part and parcel of the renewable energy industry that is on everybody's tip of everybody's tongue these days. Trials at our VDT, where we've applied for a native vegetation clearing permit for a small mining proposal. We've been backwards and forwards a fair bit. That has to, even though it's less than a hectare, it has to be approved by the feds under the EPBC Act and here, EPA under the Environmental Act here. So we're working on that to get access to there. That's been going on for a while. Geothermal power. Up at Aerosmith is one of the areas of hot rocks in WA. We've applied for 3 permits. They were released about June, July, April this year, and we've applied for 3 areas. Chances are slim, but the consequences are potentially huge. There's a lot of players that want to be playing in the geothermal market, and we're probably competing with FFI and a few others, but I doubt that they'll give FFI all of the permits. So they're all up and around Aerosmith. So once again, this is an opportunity to produce power for the project, but also power for hydrogen to make glass. The gas-fired power, we're investigating that as I mentioned, and that's a fantastic outcome if we can get that. The board, we have an experienced board. It's been the same board for over a year. The executive, we've got a new guy here, Ryan Baxter, joined us a couple of weeks ago, and he's as general manager. He's had quite a number of years involved in the production of silica sand, logistics and export. So he's a welcome addition. David is now becoming the Australian expert on silica sand because there aren't that many. There's increasingly, there is exploration into silica sand and also metallurgical test work. Most of them are following exactly what we do. So we're leading the pack there once again. Steve's our commercial manager, been with us a while. Yanil is in KL, based in KL. He just finished a road trip through Korea, Japan, Taiwan. And from that, we've got a number of major companies coming down here to make site visits. So that was a well worthwhile trip. He's very experienced in selling silica sand. We haven't issued any shares in the last year. We've still got about 7 million in the bank. We're not spending a huge amount of money. I've spent a bit of money on refurbishing some equipment. We keep an eye out at the moment for second-hand gear that now that we've got time to get refurbished, and there's a couple of other items we've got our eyes on at the moment, but the trommel's been refurbished and a major screen has also been refurbished, and it saves us a significant amount of money and increasingly saving us money because of the price of steel to replace that equipment. I guess we like to think we're positioned at the right time, right place, right commodity. This is an opportunity for WA to take advantage of the fact that, one, we've got very large silica sand supplies. As we see, there's quite a number of other players getting into this game because Asia's running out. And judging from the number of inquiries I get to buy silica sand, it is exponentially increasing. It's gone from 1 or 2 a month to 1 or 2 a week. Now, lots of those are traders, everybody trying to get in on the game, but it is indicative of the demand that is coming out of Asia to import. Now, every Asian country has banned exports of silica sand, except for there's one permit out of Malaysia, who we happen to know the operators of that, and Vietnam. Now, in June 15, Vietnam banned exports. October 15, they allowed another permit. But it is, that's it. No, there is no other seaborne trade except for out of Australia. So WA exports quite a bit, and of course there's Cape Flattery in northern Queensland. But it's an opportunity, we think, that to set up export. The bigger opportunity is to be making glass here in WA. So thank you.